In this video, we will guide you how to conduct turns ratio, magnitude and phase angle error, burden, and polarity tests by injecting current into the primary of the current transformer. Let's walk through the steps together. To begin the test, connect the device to a power source, turn it on, and input the CT information into the manager section. Once the data is entered, proceed with configuring the test settings. For this, navigate to the current transformer test menu and select the ratio, burden and polarity test option. After that, configure the test settings by selecting the phase, core, and tap under test. It's important to specify the rated primary and secondary currents of the CT, which can be done here. Next, choose the range of current to be injected. If the test requires injecting less than 10 amps into the CT's primary, select the 0 to 10 amps option. In this case, the device will use its voltage output for current injection. For higher currents, between 10 and 1000 amps, connect the ALLINA T1 plus high current output to the CT's primary. Based on the selected range, the wiring diagram updates automatically, guiding you in setting up the correct connections. During the test, the device samples the primary and secondary currents of the CT, calculating their amplitude and phase angle. This allows us to determine the ratio error and phase angle error. At the same time, the polarity of the CT is tested. Additionally, by measuring the voltage across the secondary winding during current injection, we can determine the actual burden connected to the CT. You can define the desired test current manually or use the automatic estimator. The automatic estimator calculates appropriate test current value based on the CT's rated primary current and applies it. You can also adjust the frequency of the test voltage. By default, the test operates at 50 Hz, but this can be changed if required. There are 3 options for measuring the secondary current. In automatic mode, the device directly measures the secondary current using its 15 amps peak input of measurement 1. Alternatively, you can measure the secondary current manually with an external ammeter and input the value into the software after the test. Keep in mind that using the manual method prevents phase angle error measurement and only provides the turn ratio. If you prefer, you can also use a current clamp connected to the device's 5 volts peak of measurement 3. The clamp measures the secondary current and converts it to a voltage signal, which is then processed by the device. The clamp gain value must also be entered using this option. Similarly, there are multiple methods for measuring the secondary voltage. In automatic mode, the device connects the secondary voltage to its 300 volts peak input of measurement 2 to determine the burden. Alternatively, you can measure the voltage manually and input the value into the software after the test. If burden measurement is not required, the voltage measurement can be disabled entirely, which updates the wiring diagram accordingly. While injecting current into the primary, ensure that the secondary windings of all cores being tested remain closed. If there's no real burden connected to the CT, short-circuit the secondary windings to maintain proper test conditions. If the injection cable passes through the CT core center, the number of turns must be entered in the setup. Once the settings are complete, start the test by clicking the Run button. During the test, the device displays real-time measurements, including the CT ratio and error values. If the measured values fluctuate significantly, it could indicate environmental noise affecting the test's reliability. The final results include information about the tested phase, core, and tap. Additionally, the measured values of the amplitude and angle of the injected and secondary currents, the obtained turn ratio, the nominal turn ratio, the percentage error of the turn ratio, the amplitude and angle of the measured voltage, the burden value, the power factor, the burden at the nominal secondary current of the CT, and the polarity accuracy are all displayed in the results. Here are 2 important tips. 1. It's important to ensure that the real burden connected to the CT is present during this test, because the CT error depends on the burden value. 2. If the ratio error seems unusually high, check that the rated primary and secondary currents entered in the configuration are accurate. Also, remember that CT errors are influenced by the current magnitude and burden. Low current and high burden, because of loose secondary connections, can lead to inaccuracies.